Good afternoon, everyone, and welcome to today's webinar. My name is Ray Chui, the Member Engagement Manager of ISWA, and it's a pleasure to have you here today joining us in a very interactive and interesting session. This webinar is proudly powered by Kanadevia, one of ISWA's valued platinum members, and as part of their member benefits, Kanadevia has the opportunity to host dedicated knowledge sharing sessions such as this one, bringing their expertise to the wider ISWA community. Please note that today's webinar is being recorded and it will be shared later to all participants after the webinar. If you do not want to be part of this, you are welcome to leave. Also, AI recording and note takers will be removed from this webinar. So before we start, I will just quickly run through today's agenda. So the quick welcome is by myself today. We'll also pass it over to David later to give an interactive guideline on Slido, which we'll use today, followed by Vanessa to give a quick introduction of the study and then a presentation on the study, and finally a panel discussion by Anya, and lastly we will have the Q&A for the audience. So without further ado, please let me pass it over to David to give a quick introduction of Slido. David, you're muted.
I can't believe I did that. Thank you all for joining. Yes, thank you very much, Ray, for that introduction. It's a real pleasure for us to be here. As you correctly said, this is an interactive webinar. So yes, my name is David Nowak. I'm Director of Corporate Communications here at Kanadevia Inova. This is not a one-way communication today. It's very much a conversation. So we're using Slido today. So please zap the code that you see on the screen, and you will be able to ask a question at any time of the webinar. So anything that comes up at any stage, you're curious about how something works, and then we'll get to the end of the webinar, and that's when our interactive session will start. This is a great opportunity for really constructive conversations following on from the fantastic event last week in Brussels, if any of you were lucky enough to be there. So do please ask your questions at any time. I'm going to hit a button on my machine and get us going. So if any of you have zapped the code already, you can feel free to zap it again right now and tell us, where are you joining from today? Here we see some Dublin, Essen, Valencia, wow, Zurich, UK, Red Bull, wow, Denmark. Okay, so I'm seeing very kind of DACH-centric here, but Argentina, fantastic. Thank you for joining. What time is it in Argentina? Nice and early, I should imagine. Brazil also. I think we're limited to showing 50 items on the screen here, but that's massively encouraging. US Seattle, Grenoble, Kortrijk. I have to bone up on my geography for that one. Well, as you can see, we've got a massive scope. The whole of the sort of highly penetrated waste to energy market is here with us, which is good. Again, welcome to everybody, and do ask your questions on the way through. And without further ado, I will hand over to, I believe, Vanessa Fagra, who is the Director for Regulatory Affairs and Market Access here at Kanadevia Inova. Thanks, everyone.
Hello, everyone. I've been unmuted. I hope you do see my screen correctly. Perfect. So thanks for joining us today. So as David explained, I joined Kanadevia as Director of Regulatory Affairs since now almost 4 years. And we will explain what is today the origination of this study that will be presented about methane emissions from landfills. So first, a quick start to present Kanadevia Inova. Kanadevia Inova is a green tech technology provider and project developers around the waste treatment, covering the whole spectrum of biogas, waste to energy, power to gas, trying to offer a holistic, sustainable proposal when it comes to waste treatment. Our mission is to create value for communities and to contribute to a future free of wasted waste. We have over 2,000 references globally. Our corporate is in Zurich, and I'm happy to see several of you from the company today, I guess, present at this webinar, but we are operating globally with a strong print in Europe, Europe being our historical market. Why did we start this study? I think that the waste challenge is at the core of the topic globally. It has been at the core of COP for several years. We know that waste is growing, as the latest report from World Bank Waste 3.0 emphasizes. We still have 62% of the waste going to landfills or dump sites globally. And the methane emission induced by this waste treatment is, taking more and more importance when we speak about climate change. Nevertheless, we also know that the image we have from the methane emission induced by waste is undermined. And this has been enlightened recently by recent satellite measurements, which are observing from the sky the reality which happens in our landfills. So I just share with you a video, which is a result up. I don't know how to start it, sorry. What you see is a satellite sensor detection over methane emission over landfills since 2019. And it highlights the reality of waste impact all around the world. So satellite enable to monitor facility scale level, even within complex urban environment. And what is important to say is that they reveal critical differences between annual national inventories and the extrapolated measures from satellite, with the latter being consistently 3-4 times higher. 11% out of it. It's a result of reporting. But we know now that Swiss reporting, whatever it's worth, has been undermined. And this has been enlightened by satellite measurements. The striking example is in Madrid, in Europe, where satellites detects continuous methane leaks from landfills starting from mid-2021. And this shows that the methane issue is not something solved even in Europe. And so just to end on the global sides, when we speak about this ratio, we look at 100 years horizon. And in 100 years horizon, methane is 28 times more potent than CO2. But when we go at 20 years horizon, if we look at the next 20 years, and that's where is the climate emergency, then methane can be considered as 81 times more potent than CO2, which means that if we look at the global inventory, as for now, methane only corresponds to 1/5 of the cake in terms of anthropogenic impact on climate change. But when we switch to looking at what happened in 20 years, methane is over as important as CO2 if we consider its impact over 20 years. So it's significant, and the issue is not solved even in Europe. People think we don't have any landfill issue in Europe, but when we look at the European map, and that's what I present there, it's the latest data we have, so it's a little far away, it's 4 years ago, but we can see that all the countries are red is landfills, okay? And all the countries on the right side, lots of them have over 50% of landfillings, even though in Europe, we have a target to reduce landfill to 10% by 2035. But we see that the current trend are not giving lots of hope. And that's why we launched this study, basically, because we thought, okay, there is a reality we need to highlight. The situation is not as peaceful as we think when we speak about methane emission in Europe. And we wanted to have a picture of what is really happening in Europe. What we also see in Europe, to be a little more positive, is that if we look at the picture as in 1990 and the picture now, we can say that the landfill emission have tremendously reduced. These pictures show all the countries in Europe, and they show which one. So you have the CO2 emission from waste management in 1990 and in 2021. And in green is where you have positive impact. And we see that the country who have managed to reduce the most their emission from waste are the one who have put in place either landfill tax, either landfill ban, and who have at the same time introduced lots of waste to energy facilities to treat waste. So the road has been already paved, but we are not yet there. And we still to go on reducing landfill in Europe. So that's why, we thought in 2022, we need to give policymakers a clarity on the reality of methane emission in Europe, and we launched a study with Prognos in IFOI. The context, policy-wise, was a reflection of moving waste-to-energy sector into the ETS. So EU Commission started speaking about that in 2022, and they decided at the time to do an impact assessment to decide whether or not waste-to-energy would be included in the ETS. At this time, with different associations, we have advocated to also embed in the impact assessment the landfill, so that we keep a fair level playing field between the whole sector, and we don't push back down the hierarchy waste by wrong policy implementation. And just as a company, we call Europe for a balanced decision. We do think that as for now, the waste sector is not ready for the ETS at the European level because you have too much heterogeneity in Europe. We feel that the most efficient way to reduce the emission induced by the waste sector is first to start to ban organic waste or mixed waste being landfill, and also to avoid export of organic waste from one country to another. Otherwise, all the waste, which is no more landfill here, will fly away and end up in landfill there. So that's the big danger we see coming, and we need to control that. Of course, it's also urgent to decarbonize the waste sector, also on the waste-to-energy side, by developing CCUS project and by trying to reduce the feedstock, the fossil part in the feedstock, so reduce waste and encourage recycling. But we don't think ETS is the right tool. And that being said, I will hand the floor to Bärbel from Prognos and Regina from IFOI, who have worked on the study for more than 2 years now.
Okay, I will share my screen. Hello to everybody and everyone, wherever you are participating and wherever you may be joining from. I hope you can see my screen now. As we have seen, so your journey was through the World Wide Web was a long. Partly you are coming from Tokyo, from Argentina, I have seen. So, and today I would like to take you on another journey. Not far away, not into the future, not into outer space, but right now under our feet to a place almost nobody looks anymore. A place where for decades we have been putting things we no longer want to see, especially organic waste. And when we worked on the study on methane emissions from European landfills, so one sentence hit me harder than anything else. So that methane from our landfills remain active for generations, even long after no one deposits organic waste anymore. And that is why we are here today. And let me take you through the analysis behind this. The study was carried out by Prognos and IFOI, two organizations with a long tradition of environmental and climate analysis. The competences of IFOI presented here by my colleague Regine Vogt. She is also here on the panel. The competences of IFOI are based on more than 45 years of environmental research, and IFOI has really a leading expertise in climate-related aspects of waste. And thus IFOI contributed its experience to the project, mainly in methane emissions calculations from landfilling. We as Prognos also have decades of experience in evidence-based analytics, in scenario modeling and policy assessments, among other also in the field of circular economy and climate protection. And represented by my colleague Richard Simpson and me, we worked on data collection, assessment and modeling of the amounts of biodegradable waste deposited, mainly. So IFOI and Prognos, we came together with one purpose, not to create a study explaining all the detail of the really maximum complexity that is really related to the subject of methane emissions, but to create guidance and awareness before policy decisions are made that will impact emissions in the future. So the study is, let's say, designed to shine a light into something that usually stays a bit in the dark, but to be honest, is also directly or indirectly part of the current discussions about climate and waste management related targets, about waste management improvements, about technology improvements, about financing, etc., etc. Here is where our objectives for the study came into play: to identify data sources and data gaps, to highlight differences and provide a qualitative orientation based on the available data. And let me translate them into their true meaning. So to make the magnitude of landfill methane visible, because you can only manage what you can see. To quantify how political decisions shift future emissions, because every landfill policy creates a climate pathway. To understand better the differences between countries, because averages, as you know, always hide the real story behind. And of course, also to address uncertainties openly. For this purpose, we defined the scenarios for our different, let's say, future films for 4 visions of what the world might look like, not how the world really would look like. This is much more complex, of course, but depending on what we choose. So in our first scenario, the so-called status quo scenario, we continue exactly as in 2022. 2022 is a base year because here we have the latest data available, and landfilling remains unchanged. In the so-called current status scenario, so we project forward the observed trends of the amounts of municipal waste deposited between 2018 and 2020. So every year trend is projected to the future, and in some countries these trends are positive. In others, they are not. In our third scenario, the so-called Waste Frameworks Directive scenario, here we assume that Europe actually achieves what is required, the maximum 10% landfilling of municipal waste by 2035 or 2040, in case a derogation option is applied. And only as a footnote here, so the scenario is called as a waste framework scenario because its design is based on measures aligned with the waste hierarchy under the Waste Framework Directive, which provides, let's say, a systematic framework. But to be honest, the assumed landfilling level of up to 10% of municipal waste depositors corresponds to the binding target of the Landfill Directive. And last but not least, our scenario 4 is a landfill ban. Nothing is landfill anymore from 2023 onwards. And as you can see, this was in the past. But so this is a scenario to illustrate really what could happen. It's necessary to understand the upper limit of mitigation potential. Across all these scenarios, the waste composition is kept constant for some methodological reasons. But there are some further assumptions to keep in mind, and three of them matter most. The first is that we focus exclusively on municipal and similar household waste, a fraction with the highest methane potential across all member states. Vanessa already showed the graph. Not saying that in selected member states also relevant shares of other organic waste from other sources might still be landfilled. But despite all the uncertainties and challenges, the municipal data are still the best possible data sets that is available and comparable across all countries. Not perfect, but the best we have. We model emissions only from waste landfill between 2022 and 2015. So historical waste deposits and their methane emissions are not included. The reason for this is, or the reasons for this are, on the one hand, the data availability, but above all, it is really the aim to show what will happen if we do not act now and take future emissions into account. As I've already mentioned, the aim of the study is not to present the full complexity of the subject, but rather to focus on the key issue, why we need to act. And so it's clear we need to look ahead, and that's why we started in 2022. 2050 was chosen due to the EU targets to become climate neutral. And third of all, we calculated methane generations until 2130, because decomposition doesn't stop when legislation does. Overall, these assumptions we think are conservative, and if so, they underestimate the real emissions. So please take a moment to look really at these bar charts. These present what we would call the turning point of the entire study. In the status quo scenario, so we are depositing still nearly 2 billion, so 1.9 billion tons of municipal waste, generating in total 1.5 billion tons of methane emissions, while with the scenario 2 and the further scenarios, we are decreasing both the amount of waste, of municipal waste landfilled, and thus also the emissions. In the Waste Framework Directive scenario here, we are still landfilling 0.87 billion tons of waste, generating 0.7 billion tons of methane emissions. In the landfill ban scenario, only 66 million tons of waste is still landfilled municipal waste, just creating 52 million tons of CO2 equivalents. Let's say it again. The implementation of the landfill directive in our Waste Framework Directive scenarios halves the emissions, and a landfill ban reduces emissions by nearly 97%. May it almost be too simple? Maybe. A single policy decision could really prevent around nearly 1.5 billion tons of methane emissions from being emitted by municipal waste landfilled in the EU and the UK. So if anyone ever asks you what climate impact waste policy has, I would say this slide is the answer. So again, landfills are not static places where waste rests. They are biological systems that continue working silently and slowly over decades. This is where methane is created, not in a single moment, not in the same year the waste is deposited, but continuously long after the landfill is closed and, yeah, maybe sometimes forgotten. This is why the sentence of our study, I mentioned it in the beginning, is so important. Methane from our landfills remain active for generations, even long after no one deposits organic waste anymore. And let me demonstrate it with this slide. In our status quo scenario, as you can see here in the dark brown line, almost 37% of the methane emissions occur after 2050, after we stopped depositing municipal solid waste. So 37%. That's 560 million tons of methane emissions long after new landfilling stops. And under the Waste Framework Directive scenario, it's here the orange chart, still 27 happens after 2050. So this means the waste sector is not a short-term operational issue. It's a climate policy on a century-long timescale. What we landfill today will still be emitting methane in the 2070s, 2080s, 2090s. So let's say. So as mentioned in the beginning, so we have selected some member states for a little bit more detailed analysis, as they have the highest total amounts of municipal solid waste deposited in landfills in the EU and UK. And as you can see here, the comparison between the current status and the waste framework scenario is showing that some of these member states are advancing more rapidly in reducing municipal waste deposition in landfills. So, for example, France, if you can see here, so the current status gives a signal that they will achieve the 10% recycling target, 10% landfill target. The same is true for Italy, but we have also other member states where we see opposite developments in the current status, in the current trend. It's the fact for Greece and, for example, for Portugal. Other selected countries like the Czech Republic, Romania, or UK, they really needs to undertake efforts to achieve the targets, and they have to speed up a little bit. So when looking at the methane emissions, so they resulting and they show a similar relative size by country to municipal solid waste deposited at landfills. But as you can see here, they are varying in the order of magnitude, as methane emissions do not scale linearly with waste amounts. So methane generation is not only a question of the amount of municipal waste deposited, but also a question of the impact of other parameters. And this is mainly the degradable organic carbon, the DOC value, and the methane recovery, for example, also known as gas capture rate. So we have here summarized the results a little bit from these impacts. So as you can see, some countries generate more methane per ton of waste deposited, like the Czech Republic. Here the result is 68 kilogram of methane per ton of municipal waste deposited, by using for the calculation a DOC of 0.23 and with a zero gas recovery rate. While for the UK, for example, we have only 20 kilogram methane per ton by using the IPCC default value of 0.15 and with a gas recovery rate of 56%, as stated in the National Inventory Documentation Report. So 3 lessons that can be summarized. So the amount of organic waste your landfill matters. So the amount, the technology matters. And some countries are using the IPCC default values, while others have their own calculation, their own methodology. So there are differences. So Europe is not uniform, and is not uniform regarding waste amounts deposited, landfill management, methane emission calculation parameters used, methodology used, how all this information is documented, explained, verified, cross-checked, and of course reported. So the content of the national inventory documents differ between the countries. And if Europe is not uniform, you can imagine that globally the differences are even larger. We provided also some sensitivity analysis, as you can see here. So we changed the DOC value and the R value. You can see that, of course, they have impacts and they affect the methane emissions. But as I already stated, they don't change the dimension of between the different scenarios. Yeah, we still can halve the emissions even if we are increasing the DOC value or increasing the R value. So it means that the urgency to act remain the same. So the key takeaways. So I started on, and I hope I explained it a little bit more in detail, that there are uncertainties. They are coming from incomplete historical data, from limited knowledge of historical and current waste composition. DOC values are based on IPCC value, default values. So the gas recovery is often estimated, not measured. Statistical systems are not harmonized. Satellite data showing higher values than report, because of course they are also taking into account historical values, etc., etc. But despite these uncertainties, three things are beyond dispute, we think. More waste landfilled leads to more methane emissions. Less organic waste leads to less methane emissions. And a better gas capture rate reduces methane emissions further. So, and to be honest, as we focused only on the municipal waste and excluded historical deposits, so we are underestimating methane, not overestimating it. I would like to close with the key statements that minimizing landfilling of organic waste holds really significant potential to reduce methane emissions. Or let me translate it into simpler terms. Every ton of organic waste that does not end up in a landfill protects the climate immediately and for up to 100 years. And when we talk about methane, we are talking about one of the quickest and most effective climate action measures we have. Thank you very much for your attention. And I would like to remind you, if you have any questions, as David said, please use this QR code, scan it to your phone and place your questions. Thank you very much.
Yeah, thank you very much, Bärbel and Vanessa, for this really enlightening presentations on the study content. Please, as it was pointed out, if you have been coming in later, you may always scan the QR code to enter into the Q&A, which we will post by the end of the moderated session. So from here, I would like to introduce myself. My name is Anja Schwedje, and I'm the Vice Chair of ISWA's Working Group Climate Change and Waste Management. And I welcome you all to the moderated part of the session. I will take you through the session as moderator. And from here, as you already know, those who have presented, Vanessa and Bärbel, I would like to ask the panelists, which will complement our discussion today, to introduce themselves. Starting with Regina, please go ahead.
Yeah, thanks a lot. And thanks a lot, Bärbel, already. You introduced me already for the study. I am Regine Vogt. I am co-author of the study, and I am working for IFOI, the Institute for Energy and Environmental Research in Germany, Heidelberg. And one of my main fields is life cycle assessment, especially LCA in waste management. Thank you.
I think I will follow Regine.
Charlotte, please.
Yes, thank you. My name is Charlotte Scheutz. I'm a professor at the Technical University of Denmark. My research field is waste management and resource recovery. And I've worked for more than 20 years with quantifying methane emissions from landfills and other waste management facilities. Thank you.
Alexi, floor is yours.
Yes, good afternoon, everyone. So I'm the representative of FNAD, the French Waste Management Association in Brussels. I'm the permanent representative in Brussels of FNAD. So FNAD is the association for the private waste management sector in France, so representing the collection, the transport, the recycling, and other recovery and disposal operations. We represent operators, but also equipment suppliers and consultancies which are active in this field. Thank you.
Thank you. And last but not least, Siegfried.
Yes, good afternoon, everyone. I'm Siegfried Scholz. I'm country president for Kanadevia Inova, and you may not see that now, but I have a second hat. I'm also active and speaking for ESWET, the association representing the suppliers of waste to energy technology in Europe. And we have engaged in this field some time ago when the emission trading system was first discussed. And we thought that a level playing field was really necessary to get on the same page with landfills. And when we looked into that in detail, it became apparent that this was much more difficult than we initially thought. And I'm involved since a bit more than 2 years in this research and in the preparation of the study, and also in the preparation of the oncoming studies which we intend to do.
Yeah, thank you, Siegfried. So I would like to jumpstart the discussion with Charlotte. We saw on Bärbel's presentation how long-term, how high, and also how too difficult to avoid with on-site measures like gas capture, landfill emissions are, the methane emissions. Can you just give us more detail, and why is that so, and why do we really need to act early?
Yeah, thank you for the question. Yeah, as you said, the most common practice for mitigating landfill gas emissions is to collect the gas and utilize it for energy purposes. However, we cannot collect all the gas generated. Often the gas collection efficiency is more close to 50 to 80%, but we also see landfills where the gas collection is much lower, down to 10, 20%. And why is this? There are a number of reasons for this. So first, when you landfill waste, it very quickly forms methane, even before you have the gas collection system in place. So therefore, some of the methane potential will actually be lost and emitted to the atmosphere. Second, the gas collection efficiency depends on the well design. So it could be like the spacing between wells, how deep the wells are, and also how the system is operated. Often we see that over time, wells, they tend to clog or even become water filled. So it could be due to maybe inefficient collection of the leachate in the waste. And also some of the wells become disconnected because of waste settlement. Also the type and the thickness and the integrity, you can say, or of the landfill cover will also affect how efficiently you can collect landfill gas. So if you have weak areas on the landfill cover, cracks and fissures, methane will emit through the cover. Often we actually see that landfill slopes, they are a very easy pathway for gas emissions. Finally, as that's come a little bit related to the long term, as the waste age, the methane generation will decline. And at that point in time, it becomes more difficult to collect the gas with a sufficient gas quality, because that you will have air intrusion into the waste. And then finally, maybe it's also related to this long-term things that, I mean, we should just be aware of, that landfills are not homogeneous. So the waste composition, the moisture content, the compaction of the waste, permeability, and also gas production will vary throughout the deposited waste. And this also prevent fast degradation of the organic waste, and also prevent a uniform, you could say, gas collection. I think these were some of the points, but there are probably more. Very relevant questions. Thank you.
Yeah, thank you, Charlotte. I think that showed us really the difficulty of it's a technical installation, but it's also a bioreactor, a landfill. It's a bit of a mix of both, as we discussed, and that makes it very hard actually to control landfills and emissions, much harder than, for example, in a fully technical installation, I guess. So from here, I would really dive a bit more into the member state experiences. We saw in the study that member states are different, not only in policy, but also in the factors they use. And in the approaches they have to landfills. And therefore, really, what measures in your countries you deem effective to prevent the methane formation and thereby also the methane emissions from landfills? What is the prime policy or the prime legal requirement for that according to your domestic experience? And we have 3 countries here with us. That's France, Germany, and Denmark. So I would ask Alexi to start from the French point of view, followed by Siegfried and Charlotte then.
Thank you very much, Anya. So, well, during the transition phase and in regions where full waste treatment capacity is not yet available, we believe that well-managed landfills remain an indispensable component of a circular waste management system, being a resilient and a modular waste management system. So we also, of course, we are strongly supporting the idea that it's important to avoid biodegradable waste entering landfills, because this is obviously the purpose of today's discussion. Less biodegradable waste in landfills prevents emissions. But where in many areas where this cannot yet be fully achieved, minimizing methane emissions is not a nice to have, but an operational necessity when you run a landfill. So in our view, the French experience illustrates a pragmatic and a balanced approach to waste management that takes into consideration different local conditions, different collection systems, differences in infrastructure availability, differences in individual behaviors, differences in financial capacities of municipalities or local territories, differences also in social acceptance of the different waste management systems. So rather than imposing a strict ban on landfilling of biodegradable waste, France is combining a steadily increasing landfill tax, which is at the level of 65 euros per ton today, which will increase to 85 euros per ton by 2030. It has just been adopted in our recent budget, with a robust regulatory framework ensuring high environmental performance. So this is basically the 2 main policy levers that we have in France. The environmental impacts linked to the presence of biodegradable content in non-hazardous waste landfills are quite well managed in France, and they rely on advanced techniques such as temporary capping, gas capture during active filling phases, typically within 2 years per cell closure strategy, and also emissions monitoring. This management method is known as the bioreactor system. Charlotte touched on it. I mean, those are bioreactors indeed, the landfills. And this has been a standard applied in the design, construction, and operation of landfills in France since the mid-2000s. And this bioreactor system offers many advantages, among which the recovery of significant quantities of landfill gas, and also the accelerated biological stabilization of the landfill. Moreover, the leachate recirculation, which is something that has been allowed in France since 2006, helps in a regulatory context whereby you have less and less organic content that will be allowed in landfills, that result in the core of the landfill becoming drier and less prone to anaerobic decomposition. But it also acts, in fact, as a fire risk mitigation measure as well. So looking ahead, as separate collection of bio-waste expands, we have this now in EU legislation since 2024, and landfills input are further restricted in line with the landfill directive. We have the 10% target by 2035, the biodegradable fraction will continue to decline. So in that context, landfill operation will evolve, clearly placing greater emphasis on the rapid stabilization via leachate recirculation of residual waste, and progressively less on methane recovery. So if I summarize in one sentence, the way forward, clearly methane prevention starts upstream, but where landfill remains necessary, performance-based regulation, and high operational standards are key to minimizing emissions.
Yeah, thanks, Alexi, for sharing your point of view on this. And of course, we can agree with your conclusion. I would just like to add that in Germany, we have been very successful with the landfill ban of biodegradable waste, which was established in 2005 and which led to reduction of methane emissions by 95% up to now. We have seen in the previous presentations how long-lasting these emissions are, basically for generations. And in Germany and also in other countries which have established the ban, it has proven quite successful. So improving landfilling operations like you do successfully in France is certainly a good thing. But the better solution, to my mind, would still be to avoid biodegradable waste to be landfilled in the first place, if that can be done. The best way to get to this point, of course, would be to increase recycling rates, but also to increase the ratio which is treated by thermal waste treatment by waste to energy technologies. This is not a contradiction. Both can be increased, as several examples have shown, at the same time. And yes, everything like improving the landfills, the landfill operations, the technology of the landfills is an intermediate measure before we really avoid landfilling of biodegradable waste completely. That's what we have seen in Germany, and it would certainly also work in other countries.
So I can say a few words about the situation in Denmark. So Denmark implemented a ban on landfilling of organic waste already in 1997. So that's close to 3 decades ago. And started then incinerated the organic waste together with the residual waste. And also implemented, in addition to this landfill ban, different landfill tax and taxes and different waste management alternatives. And together with the waste incineration, not only using the electricity, but also using the heat, implementing district heating in a rather large part of the main cities. And so today, less than 2%, I think, of all generated waste, not only the organic, is landfilled in Denmark. Now time has changed a little bit, so it's not only about waste incineration and electricity and heat recovery, but it's also about resource recovery. So now we sort out the organic household waste, and it's sent for anaerobic digestion so that we can still produce biogas. We upgrade it to primarily upgrade it to biomethane and replace natural gas in the national gas grid. And then, of course, the nutrients and the organic carbon in the digestate is spread on agricultural land. Yeah, so that's the situation today.
Yeah, thank you all three by taking us to exactly the diversity or part of the diversity we have inside Europe. Yeah, and probably also the challenge how we can shape a common European policy. Interesting discussion from here. I mean, we need to look into one aspect. No matter if we divert a maximum of biodegradable waste from landfill, probably also through economic measures, or whether you do a landfill ban, in the end, the waste has to go somewhere. And Charlotte already, as Siegfried and you, Alexi, mentioned some of the technologies which you then have to use in order to kind of treat the waste. And so my question would be for Regine now, from the science point of view, when you look into all the different types of treatments which you have, are these all net zero technologies, or do we really have to count with greenhouse gas emissions when we don't have it in the landfill, and at what scale are they compared to landfilling, to direct landfilling?
Well, thanks a lot. Yes, of course, we heard about the alternative treatment options. And well, to start with, from an environmental point of view, I think it is the best option to do source segregation, actually, to really collect the organic waste separately at the source. And then we have like the most well-established technologies, composting, or also anaerobic digestion with after composting. And with the potential of net zero, there with these treatment options, we have the additional benefit of products like compost from the composting, or also energy biogas from the additional anaerobic digestion. And these products do have the potential to substitute primary production or conventional energy generation, like compost can substitute mineral and organic fertilizer. Biogas or energy from waste can substitute the conventional energy generation. And if we take into account these avoided emissions, then of course GHG balances could be net zero, or they could also be negative. But we shouldn't so much look only at the avoided emissions, because they are potentially avoided emissions, and more important, they change over time. I think if we really want to reach our climate protection goals, in 2050, energy should be climate neutral. So there won't be any credit anymore. There won't be any avoiding anymore that we could count for. And also, for example, for organic fertilizer, nowadays it is a really good thing to substitute peat. But peat extraction should be forbidden in the future. It should not done anymore. So there would also be no credit anymore. But if you look at the direct GHG emission only, then organic methane emissions from landfilling of organic waste is combined with the highest GHG emissions. If from our study, from the parameters we used for our calculations, we came to a range for the different countries, for the different regions, lying between 500 kilograms CO2 equivalents per ton waste, going up to 1,800. The range Barbara showed in this specific results value chart. And we know from German measurements, and also if you take the IPCC default values, that for anaerobic digestion with after composting, you have on average, on mean values, GHG emissions in the range of about 200 kilograms CO2 equivalents per ton waste. And while in both cases, there are, of course, optimization potentials. And just talking now about what we know from German measurements, there are anaerobic digestion plants with after composting in operation in Germany, which can realize GHG emissions which are as low as 30 kilograms per CO2 equivalents per ton. These, of course, are top runners, definitely top runners, which do have very good technology installed. But also, if you look at, they are also very simple technologies. So if you only look at composting, there is the possibility with just simple open composting, just with the roof above it. If you have small compost heaps, if you aerate them well, then it is also with these best practice possible to be at the lower end of GHG emissions per ton of waste. So from a climate protection point of view, it's not so much needed to really get the net zero, but to get it as low as possible.
Yeah, thank you, Regina, which shows that as long as we are in a fossil world, we are a sector which really contributes to substituting the fossil world. Once the world is defossilized, hopefully, there is still a remaining emission from the waste sector because compensation is lower. But I guess in comparison, just to ask you very directly, if you compare direct landfill now and starting the diversion, starting the ban, we saw the study has shown the amount which you can really reduce. Does that mean that most of the diversion technologies, yeah, everything which happens to the waste when it's not landfilled, usually have a much smaller impact in greenhouse gas emissions compared to landfill. Could we say that, or does it depend very strongly on the technology we use?
I would say it's not so much the technology, it's best practice. If you think of composting, with anaerobic digestion, it's a bit more difficult there. It's more technology which needs to be advanced, definitely. And there are further, there's so much research nowadays in the world with doing things with biogenic waste, with organic waste, like bioreactors and biorefineries. There, it's too early, to my feeling, to really say where it is going, if it can be as low also, or if it's not a good option to do and to follow. That's too early from my point of view.
Okay, yeah, thank you. So we are actually in a very interesting field, the waste sector, and where do we end up in 2050 in terms of our greenhouse gas emissions? And that depends very much on how quickly we advance. I think that is what you pointed out very well. So quick advancements. The study also showed that we really, if we continue on the current pathway, we still have a remaining relevant methane potential, emission potential in our landfills. And I think that was the most striking result which you showed, Bärbe, from the study. And the factors are multiple, as you explained, but looking into the overall picture, if we fall short as a sector, if we have these long-term emissions beyond 2050, yeah, do we need more coherency between current climate and waste policy on a larger level? And how would we compensate these methane emissions, which really take us through almost the century? So that would be a question here for Bärbel and Vanessa. What is your picture? What happens in the EU overall? Bärbel, please.
Yeah, thank you, Anja. So yes, so as you mentioned, the study clearly shows that under the current implementation of the legal framework, the EU still would have substantial methane emissions from landfills in 2050. And this means, of course, that the climate and the waste policy are currently not moving in the same speed, because climate policy sets the neutrality target for 2050. So we need a more coherence. So we need to align it we need timelines to align. We need to align the ambitions, climate neutrality and the 10% landfill target. For example, here we are with landfills. We need to align also the implementation. So because we have a gap between EU law requirements and the what actual happens in the mean in this. And of course, you mentioned if it's a compensation. So yeah, the risk is real that we have to compensate it. And as methane detection improves, so I think Charlotte mentions the satellite measures. We have compliance systems which will define stricter regulations. Landfill methane could or will become financially costly for the sector. And for me, it's my personal opinion, avoiding emissions, avoiding organic waste landfill is far cheaper than compensating them for them later. And to be honest, to invest the money into recycling, into prevention, into other options, for me is much more effective than continuing to improve landfill and investing in gas capture system, etc., etc. Yeah, it's my personal opinion.
Yeah, thank you, Bärbel. Vanessa, you introduced us to the reasons why the study was actually triggered. And that contained already some of the elements of my question as well. So what is your view on it?
I mean, I'm fully aligned with Bärbel. And I think for the one who have been there last week on the 26th of March, it was cruel, I mean, highlighting of the lack of coordination even at EU level between the DG Klima and DG Environment. And as you said, Bärbel, we see that people who drive the climate have this net zero by 2050 urgency, but they also, we see that today, I'm personally convinced that the EU ETS is not an efficient tool to decarbonize the waste sector, that be waste to energy, but also landfills, because it's a lot more efficient just to avoid to have any organic, but not only organic, mixed waste into the landfills. Because just a point to react on what Regina said, it's not as easy as we think to just pre-sort organic. We consider that 15% of the plastic is contaminated with organic. So this plastic, if it's pre-sorted, if it ends in landfill, it will still end in methane degradation, and it's not solving the case. So whole mixed waste present a risk of methane legacy. And so I think what we see today is they are not working at the same speed, and we cannot solve the waste issue if we don't have a strict framework from landfill. And we know that as for today, we don't have reliable data for landfill methane emission, which enable policymakers to tax them. But we also see that science is moving. We also see that we have visibility on the data gaps when it comes to reporting, to data. It's what Prognos study has shown. There are lots of discrepancies, so we cannot rely on the reporting. And as for now, we cannot yet fully rely on the satellite measurements. But science is moving. We have more and more studies, and it will come. I think within 5 years, I'm sure we will have a far more reliable measure of landfills impact. And what I see is that there is this EU methane regulation. As for now, it's not, embedding the waste sector. It's only concerning the energy sector. But I see that at one point, Europe won't have any other choice than including the waste sector in this regulation. And then all the as you said, the legacy of methane after 2050, when we will be supposed to be net zero, will be highly costly, and we won't be able to just compensate it with carbon removal or carbon credits in other countries. So we will have to act, and it will become soon an emergency. So I have hope on my side.
Yeah, thank you, Vanessa and Bärbel, highlighting that timing is crucial, coherence is crucial. And so now my question, if we look at that, what would be your number one topic? And you have 1 minute, please. Your number one topic you want to change in European strategies, legislation, or whatever to address that problem. And probably we get an area of views here of what's going on, either reporting waste data, the landfill directive, also maybe the bad breath process, whatever you like to mention, it's now on your plate. And we go through it. First Alexi, then Bärbel, then Vanessa, and then Charlotte. So Alexi, you start.
Yeah, I'm sorry I have 2, but I stick to the 1 minute, hopefully. So clearly the number one priority is the full and harmonized implementation of the the existing EU waste framework. So by that I mean the targets under the waste framework directive and the targets under the landfill directive. Much of the expected methane reduction is already embedded in these instruments. For example, for us, separate collection of bio-waste, even though it takes time to roll out, is clearly the number one instrument that will prevent bio-waste from entering a landfill. Restrictions on landfill inputs of municipal solid waste, obviously, so referring to the 10% target by 2035, is also an extremely powerful tool. We have seen on the chart that was shown by Vanessa that some countries are behind quite late, but indeed implementation remains uneven across member states. So in that context, I'm bringing my number 2 main priority, which is the upcoming landfill BREF. For us, that instrument will play a key role promoting what we could call advanced landfilling, so combining high methane capture efficiency, production of green energy, where net zero could almost be at reach. I mean, some of our operators in France believe that the capture rate is nearing nowadays 90%. So it's possible. And even when residual organic remains in the waste after waste policies are properly implemented. So this is essential not only for future waste streams, this policy, so the BREF, but also to address emissions from existing and legacy sites. I think that we shouldn't overestimate also the emissions which are already in the ground, arising from waste which is already in the ground. So at the same time, improving the robustness of emissions monitoring and reporting should remain a priority, and we will work on that in the context of the landfill BREF. Current modeling approaches still involve significant uncertainties. You have mentioned it in the presentation, and especially regarding waste composition, because I think when I look in the questions, in the slide already, some comments have been made already on the fact that the quantities of municipal waste reported per country is not always accurate. So at the end of the day, uncertain data can affect the accuracy of emission estimates and ultimately policy decisions. So again, concluding, better implementation combined with advanced landfilling standards, for us, it's clearly likely to deliver faster, more reliable emission reductions than new legislative targets alone.
Okay, it's similar to my opinion, but if I had to choose one priority, it would be a mandatory harmonized EU system that measures methane emissions from landfills accurately, or also the waste amounts deposited on the ground, from the air, from the space. Because today we are sometimes, or mostly, we are flying a little bit blind. Reporting is inconsistent, methods vary, capture rates are partly guessed, and satellites already shows that real emissions are often higher than what we report. So to strengthen EU monitoring system, for me, would really do 4 things: to make methane visible instantly, to reveal the biggest sources fast, to turn obligation into real accountability, and to link waste and climate policy, because methane becomes measurable and therefore manageable. So in short, the strongest, fastest lever is better methane monitoring. Thank you. I hope the 1 minute.
You did your 1 minute.
Super.
So I think it's my turn. I'm aligned with you, Bärbel, but I won't take this one priority. I think Europe needs simplicity. I think our industry needs simplicity, and we need to stop burden industry with too complicated regulation. We see that there is a simple way to reduce the impact of waste, and it is zero organics to landfill via strict source separation. It doesn't require measurement. It doesn't require Annex B, C, D on any regulation. There is no locking effect because AD and composting, as Regina has said before, are clear solution, and it doesn't take lots of time, neither capex, to implement. So for all we have some solution and we have capacity. So that would be something simple. And we see that with the landfill directive, the target, we only halve the emission, but we need to do more. As for today, the landfill directive target is not enough. And I see that if we include waste to energy in the ETS, it will be fragilized. It will be pushed away. We already hear that some country ask for derogation to have, some more time before closing their landfill. It will happen. So it is already at risk. So we should reinforce it. That's it on my side.
So Vanessa, quick question back would be that you want to have what directive or strategy changed with what thing?
A European, I mean, a mandatory mandate to zero organics to landfill at the EU
Okay.
level
And-
via source separation. No?
Yeah.
No MBT, because the risk is that we see MBT popping out everywhere. So also.
So you want to address the legal waste framework to be more stringent. So
Yeah.
Charlotte, over to you. What is your number one?
And I guess my number one is that I would really like the member states to step up. I really believe that we have all the needed regulatory drivers in place, so very much in line with Alexis. And we have more than that, actually. We know how to divert the organic waste away from landfills. We can design waste management systems where we have anaerobic digestion, composting, and other technologies as part of that. And we also know how to mitigate methane emissions, improving gas collection at the landfills where we have organic place already landfill. And we can also monitor emissions. So we do have different monitoring methods available, and we can discuss that a lot. So I think if we look in the toolbox, we have everything we need. But what we lack is really, you could say, national commitment, implementation and enforcement of all the good things that is already stated. I'm not against that we update European strategy documents and so on. And BREF, I think, can be very good. But let's not use that time that this will take to do very little. We can already start. We have everything we need.
So you call for quicker movement of the member states under the current framework?
I think if we look at the landfill directive, it goes back to 1999. And already in that document, if you read it, it is set there already what should be done. And this is now, I mean, we're getting close to 3 decades ago, right? And there's been updates and so on, but it was actually already stated in there. So that we should divert organics away from landfills and so on, and we should monitor the gas and all these things. Didn't say how to do it, but so I think it's time for action, really.
Yeah,
we know how to do it.
Thank you for that, Charlotte, because I think really, yeah, you're right. We know how to do it. And what was already addressed in this round is the question of monitoring, reporting, and verification of the data. Yeah. So when it comes to landfill emissions, what prime technical data or methodology challenge should we address? Yet again, one topic, one pick, 1 minute. And the call is for Regine, Charlotte, and Siegfried in that order, please.
Well, thank you. I'm just still reflecting what Charlotte said. We have the toolbox ready. I completely agree with that. Sorry to say. Sorry that I convinced with that. But it doesn't really happen. So the push is missing for the countries, and I really hope that our study may give a further push. As for MRV, sorry. I think MRV is in general a challenge for landfill methane emissions because what already was explained from Charlotte, we have this huge inhomogeneous landfill body where it is really difficult to get fugitive methane measurements in a representative way. Then there is satellite-based data, but with both you have like a snapshot over the landfill body, like you get the current methane emissions, the current fugitive emissions. What is a further complication is that the methane generation is so slow, the degradation process is so slow, and is taking place over this long time period. So the major challenge to my thinking is how to relate these measured methane emissions to tonnage of waste. How do we come to a kilogram CO2 equivalents of methane per ton of waste? I have actually no idea. Therefore, I think the IPCC methodology is still the best that we have in place. It is internationally accepted. We used it also for the study for this reason. And of course, there are improvements with regard to the parameters. It was already mentioned that the degradable organic carbon, the DOC, is a major parameter for the calculation of methane emissions. The DOC can be derived if you know your waste composition. And there it is from our learning that many countries do have a country-specific waste composition, but for me it's not clear how they get to this waste composition and how representative this composition is. And I do think that a standardized rule can help to improve that, with a standardized rule for the European level telling how the samples should be taken, how often the samples should be taken, where it should be taken, to come to a more harmonized basis of waste composition and thus for the DOC. But I won't restrict it to waste going to landfill. I think it's in general important for countries to know what is in their waste, and there should be like a standardized rule for sorting analysis of residual waste. Thank you.
I can follow up. So I think for the national reporting, we can rely on the IPCC reporting framework. I agree with Regine that we could work towards getting better data and use it more consistently within the European Union. So I think this framework is good enough for what we can say consistent and transparent reporting, inventory reporting at the national level. But in that framework, we consider one big disposal site in each individual country. So I don't think this framework is good enough if we want to regulate anything at the landfill specific level. So if we were to implement any kind of regulation at different landfills, we would need better, more precise data. And I think this can be obtained with more monitoring, and it's not a trivial task. I agree with this. It's measuring how much methane is emitted from let's say 10, 20, 50 hectare landfill. It's a difficult task, but it can be done. So there are different methods available. They are already available today, and all methods, they come with uncertainty. Some methods have lower uncertainty than others, and of course this is also a result of many years of development. So I think one of the issues now is that there is no incentive for landfill operators to have their emissions monitored in the way that I talk about it now, where we want to know more about the total methane emitted from the site. But once that incentive would come in place, that would also give a push to service providers developing new methods, and these providers, of course, needs to be accredited somehow. I mean, you need to become a professional in doing these emission measurements to get it right. And of course, there are standardization schemes and accreditation schemes that we know from other methods. I know that it's more complicated for these methods because it's not only about analytical instrumentation, it's also about the whole application part of it. So it's not trivial, but it can be done, and we can learn from other sectors, and we need to become professional in doing this. And of course, there needs to be some sort of license to operate when it comes to providing these data. And we can discuss that emissions, they vary over time and they are dynamic and all this, but think about it. If we for the last 20 years had just one annual methane emission measurement from each landfill site in Europe, how amazing would that not be? How much would we know more than what we know today? I think we need to get started.
Thank you, Charlotte. Siegfried, please stay brief because there's already so many questions popping up from the audience.
Yeah, I don't want to waste time echoing what Regina and Charlotte have said. I fully agree that there is a lack of verification of the first order decay model used for the reporting to UNFCCC, and this can be much improved. I agree that the measurement of methane is possible, of course, but we should also not forget the other pollutants which are emitted by landfills and which also should be controlled, and also the degree of accuracy, which necessarily is much lower for landfills than it could ever be on waste energy plants, because there you have defined outlets and the measurement accuracy is much higher. And well, that brings me to the consequence of that. If we know, even if the best technologies are used for the verification of the emissions from landfill, then if taxes are involved and we want to be on a level playing field, then we need to be on the safe side. So we need to make sure that the emissions from landfills are conservatively estimated or verified.
Okay, thank you, Siegfried. So now over to you and to the audience and your question. David, would you just kindly show what's the top ranking question in our Slido? So the top ranking one apparently is what you just marked in green. What are the assumptions regarding the waste that is diverted? If less waste is landfilled, what happens to it and how do these assumptions influence the results? Who of the audience likes to take that question? Bärbel is lifting her hand. Please, Bärbel, go ahead.
Yeah, I think it's because we modeled the waste amount, so I think it's a question to us. So for this study, we were looking really to the waste remaining landfill. So we didn't specifically define all the measures which could taken. So we in general checked only what's possible. So we have the separate collection target for bio waste and green waste, so it's going out. We have the reduction targets and for food waste. So this is waste going out. We have other prevention measures. So it's up to the member states. So we really we are looking on what's the remaining waste amount. So we still will have some biodegradable waste in mixed waste streams because it's combined with other fractions, as Regina mentioned. So this is what goes to other treatment routes when we are saying that to pre-treatment routes like MBT or to waste to energy, but it will not influence our, so these assumptions will not influence the results because we were focusing on reducing and banning the remaining waste. But measures are possible and it's possible to come to this avoiding.
Yeah, thank you, Bärbel. So going to the next question on Slido, if I interpreted it correctly, the question is related to the landfill ban and whether the emissions from the alternative scenarios, exactly from the diversion scenarios, have also been considered. That goes a bit into the direction which I asked before. Are we deleting all emissions or is there still something to be expected? So who from the panel would see fit to discuss this? Regine is lifting. Yes, Regine, please.
Thank you. Just from the scientific or from the calculation point of view, I want to follow up with what Bärbel said. From the study, we really sticked to the methane emissions from landfilling of organic waste, and we didn't look at the alternative scenarios. We just really wanted to look what is happening under different circumstances for methane emissions from landfills. Just to add on this, and then there are others in the round for answering.
Yeah, Charlotte has lifted her hand and then Vanessa. So please, Charlotte first and Vanessa next.
Yeah, so I hope I understand the question correct, but of course you need to look at holistically at the total system. So when you start diverting organics away from landfill, where will they then go? And it could be for waste incineration, it could be for composting or anaerobic digestion. So that's why we sometimes use life cycle assessment to model systems in this holistic from a holistic perspective at the system level, you can say. And so we have tools to do those kind of assessments. And of course, there you also need to include emissions from the alternative treatments. So that could also be emissions of methane if you have leakage from a biogas reactor, or you can have methane and also a bit of nitrous oxide emissions actually from composting of organic waste, and that needs to be included. But then you also have benefits. So depending on which kind of treatment, and Regina talked about this and also talked about this, how those benefits from substituting, whether it's fossil energy resources or it's fertilizer or peat, whether the benefits from that will change over time. For example, as our energy system becomes more green, we have more wind, other kind of renewable resources in the energy system. So then the benefits will change. But studies are being done, and we have methodologies to include methodologies to do these kind of assessments. And then, of course, it's not only climate. We're talking about climate today, but there are also other things in terms of, for example, pressures on different resources.
So I see Vanessa and then Siegfried, and then we will conclude the reply to that question and go to the next one. Vanessa, please. Vanessa, you're on mute. Could it be?
Yes, excuse me. Quickly, that was not the goal of this precise study, to look at the alternative path, because of course it's not that the goal is not to replace all the waste which won't be landfill and to send it to waste to energy. The goal is to get the most valuable value out of the waste we take out, respecting the waste hierarchy. So of course, I mean, if you are pure organic, anaerobic digestion is the priority. We know we need local biogas in Europe now more than ever. So I think there won't be any question on the use of the feedstock, of the product at the end. And to answer this question, I think Prognos has made a really good study with CWEB in 2022, which was looking at the global picture of how to avoid emission, and they looked at the global solution. So that's why we didn't redo it. We just focus on methane emissions in this particular study. And maybe, yes, maybe Bärbel, you can share the link after, or we can share the link to the participant of the study, which has been made.
If I may, Anja?
Yeah.
Yeah, I would have said very much the same thing as Vanessa on the previous question, but maybe I can answer this question, which is now in green on the screen, which is regarding the introduction to the ETS framework. And
okay,
I think
then Siegfried, let me quickly introduce the question.
Please.
We have the next Slido question. How can we actually introduce landfills into the ETS? And the question to the entire panel here to elaborate a bit more on that. And Siegfried, you come first serve, followed by Alexi.
Yeah, thank you. So basically, my response to that would be that the methane emissions from the landfills need to be assessed as accurately as possible, and then the conservative side of that estimate needs to be taken into the ETS, so that we are sure that is an appropriate amount comparable to the amounts also recognized for waste to energy. But that is not the whole thing, because once that happens, everyone should be aware that for waste to energy, the fossil components are taxed and turned into emissions, and for landfill it is the biogenic part of the waste. So there will be an incentive to move waste from one to the other, from waste to energy to landfill and vice versa.
Thank you. Alexi.
Yeah, it's a complex question, but I think, I mean, right now we are definitely not there when it comes to including landfills in the ETS. I agree with Siegfried. I mean, once we are able to better measure the emissions, to measure them more accurately, then we will have moved a little bit forward. But we shouldn't also forget that there are, I mean, landfilling is rather complex. We are also talking about emissions after the site has stopped to operate, so during the aftercare and after the aftercare. So how are those kind of emissions taken into consideration in the ETS framework? That's also that's also a real question mark, and something which, I mean, does not exist as per the current system. I would also highlight that, I mean, equally to waste to energy, landfilling is a public service. We are not like other operators currently subject to the ETS, where you can, as a mitigation measure, you can switch your fuel. In the waste sector, you cannot switch the waste with something else. I mean, you have to treat the waste, and we have said today that in some areas, I mean, for the residual waste, there are not different options available. So those are a couple of arguments, and then I fall back to my kind of my main priority right now, which is the landfill breath. The landfill breath was opened for two main reasons. One reason is PFAS. The second reason is greenhouse gas emissions. And I think we have to work seriously under the landfill breath to ensure that best available techniques will be derived to mitigate the greenhouse gas emissions. When it comes to addressing the level playing field, because I'm hearing what you are saying on the level playing field, I think that the waste form, the environmental legislation, and especially the current work that DG Environment is doing to try to approximate levies that exist in many member states right now on landfilling, could be one way to establish such level playing field.
Thank you, Alexi. And with this, I unfortunately have to conclude this very interesting discussion and webinar in the interest of time. We are already 1 minute over time. I would like to thank all the speakers and the panelists, and also the entire audience which was with us. And thank you very much for your attention, the good questions, the interesting answers. And we guess we stay on that topic because it is not over yet, as most of the discussion has revealed. Back to you, Ray. Thank you
so much
for the floor.
Thanks so much, Anya, and thank you everyone for joining today. Also, thank you to all the panelists and Kanadevia as well as one of our partners as well. I would like to thank everyone again for joining. For the questions that were not answered today, we will try to address it via the speakers after this, and we will try to circulate it out also to our participants today. And for those who missed it or would like to rewatch it, a recording will also be sent out to all participants. Yeah, thank you everyone again for taking the time. It was a really good session, and hopefully we'll have a next one to discuss more topics like this. Thank you, everyone. Take care.
Thank you very much.
Bye.
Thank you.
Bye-bye.
Thank you.
Thank
Bye-bye.
Thank you. Bye-bye.